Hello students and friends, I am Manoj Verma from Mumbai in India, and in this video I am going to solve a problem which is based on finding out the pH of a buffer solution. And I have taken this particular problem from the Pearson edexcel International Advanced Level Examination, and they had set this question in the sample assessment material which they had set for the first teaching in September 2018. The paper reference is WCH 1401. And the problem that I am going to solve is a very basic problem, and it is applicable to the students of Cambridge advanced level also, and the students of IBDP can also benefit from this problem because a similar type of problem can be asked in their exam. So I'm going to focus specifically on the question which deals with the finding of the pH of a buffer. So let's focus on that. So as you can see here that the question says that 10 centimeter cube of 1 mole per dm cube sodium hydroxide was added to 30 centimeter cube of 1 mole per dm cube propanoic acid whose Ka is 1.3 times 10 raised to minus 5 mole per dm cube, and you have to calculate the pH of the resulting solution. So I have written down here the two reactants, that is the propanoic acid and the sodium hydroxide, and the reaction that's going to take place is the following. You will get sodium propionate and water, but you have to be very careful here about the number of moles of the NaOH and propanoic acid being used. So if you see here that we have got 10 centimeter cube of 1 mole per dm cube sodium hydroxide and 30 centimeter cube of 1 mole per dm cube propanoic acid, as it is obvious that they are not in the exact proportion, and just by observation you can see that the propanoic acid is in excess because it's 30 centimeter cube 1 molar and this is 10 centimeter cube 1 molar. So NaOH is obviously the limiting reagent and propanoic acid is the excess reagent. So by the normal method of calculation of the number of moles, this will be 1 times 10 over 1000, and that will give you 1 times 10 is to minus 2 moles, and this would give you 1 times 30 over 1000, that is 3 times 10 is to minus 2 moles. So since they react in the ratio of 1:1, it is obvious that the NaOH is the limiting reagent and the propanoic acid is the excess reagent. So out of 30, 3 times 10 is to minus 2 moles, only 1 times 10 is to minus 2 moles of the propanoic acid would be able to react, giving you the same amount of the sodium propionate, and 2 times 10 is to minus 2 moles of propanoic acid would remain unreacted. So the amount of the salt form would be 1 into 10 raised to minus 2 moles, and the amount of the acid left would be 2 into 10 raised to minus 2 moles. This is the important part that you have to understand about the excess and the limiting reagent, the amount of the acid which is left over, and the amount of the salt which is formed. Once you understand this, then the rest of it becomes clear. Using this equilibrium equation for propanoic acid, you can write the expression for Ka, which is the products over the reactants, and rearranging to get the concentration of H plus, you get Ka times the concentration of propanoic acid over the concentration of the salt, and as we have seen that the value of Ka is given as 1.3 times 10 raised to minus 5. This value we can take over here, and the ratio of the concentration of the acid over the salt is, you can see, 2:1, because 2 and then 1, this is the ratio. So we can write that ratio, and then when we solve it, you get the concentration of H plus as 2.6 times 10 raised to minus 5 moles per dm cube. And then when you find out the pH, it is the negative log of the hydrogen ion concentration. Put the value of the hydrogen ion concentration as this, and you get the pH as 4.59. So that's the pH of the resulting buffer solution. Alternatively, this problem can also be done by using the Henderson Hasselbalch equation, and I will show you the working of that also. So the formula used is pH is equal to pKa plus log the concentration of salt over the concentration of acid. And so we should find out first the value of pKa, which is minus log of Ka, and you put the value of Ka over here, and you get the value of pKa, which is 4.886. And now pH is equal to pKa, which is 4.886, plus the log. It is now the concentration of salt over acid, right? So now the ratio is 1 over 2. As you can see, the acid was twice the amount of the salt. So this is 1 over 2. So log 1 over 2 is minus 0.301, and you solve it, you get the pH as 4.58, which is the same as the value 4.59, ignoring the minor difference in the decimal place. So you can use either of the methods and solve for the pH of this buffer, but you have to clearly remember that you have to use the concept of the excess reagent and the limiting reagent to understand the final concentration of the acid and the final concentration of the salt. Hope you understood this. Thanks for watching, and if you like this video, please give it a like and subscribe to the channel, and also share it with your friends. Thanks a lot.